Let me go ahead and share my screen. So, I know last week was crazy, right? Um, Ice and snow in Texas, everything shut down. As a result, and because you guys hadn't really had any um, real kind of look at how a love game would work inside of, well, how a love game would work in general, I went ahead and I did push back the due date for you guys as far as your game goes. It's not due until after spring break. Um, Granted, that may butt up against a lot of the other things that you guys are doing for midterms, so just, you know, um, get this done. So, what we're standing at right now is nothing else has changed as far as the schedule goes. And if you come into your modules, you can see we still have, everything is still basically set up the same. I am going to say that there are a couple extra things other than what I'm going to show you today, which is a different thing, that would possibly be helpful. You have My Love, you have a pre-recorded lecture, Making a Game in an Hour. That's a chicken drop game. There's a simple board game example. Again, if you go to my REPL, there's a few other examples. There's tossing dice, there's a clicker game, there's a maze game with some simple collision. And then we'll actually come back, and I know this says it's the 6th, but it's actually due the 20th. I just haven't changed the names or anything on here. So what'll happen is we'll come back on this date that's Python, and we'll still do all the Python stuff, but you will also have all of this stuff too. So it's kind of the trade-off. If you look at the calendar, it's a little bit clearer. Oh, cool. It's set up for you guys. So we are here. And your game is going to be due in March. And it's going to be due, like you see, here. Okay, so with that kind of out of the way, what are we going to do today? Or what am I going to do today? Well, I'm going to walk you through this code. I'm going to actually code it, so I'm not going to just like sit here and talk about the code. We're going to actually, or I'm going to actually code through it, and if you guys are following along, you can code as well. It's about 200 lines, and it's the start of something that could be called a game. If we click the play button here, and again, you can also play it from wherever you're at. Okay, so I had this problem last night where for whatever reason this REPL's not a happy camper. So, let's just do this the dumb way, or I guess the smart way. It depends on what you're doing. So, what we're making today is just a very simple, yeah, the barrels are super menacing, right? And we can fire bullets, they collide, they explode, the explosion goes away. So, it's the start of something. This is not really a game, it's not compelling, but it is something that is definitely a start of something. And I talked about one of the things that I kind of wanted from you guys was, if you possibly could, to have kind of a scene switch where you've got a title screen or an end screen and an end screen. And that's kind of what this will show. It very, very simple. It hits the left screen and game over. So hopefully REPL's gonna actually do its thing today. This code is also in my REPL. You guys can look at it if you want. One we're going to try and keep things super, super simple insofar as we're not going to do a lot of extra functions. We're going to keep everything kind of in main. Well, we are going to keep everything in main, but we're going to keep everything basically in load. We're going to have a mouse pressed function though, which is built in, update, and draw. So the only extra function we're going to build, and we're not going to build it for a while, is going to be this barrel spawner. And that's because we write this so many times that we might as well have a function for it instead. So what I'm going to do is I'm going to come over here and I'm going to make a new REPL. Love TD, and I'm going to just leave whatever name it happens. Silent Profitable Computers. That's actually pretty nice. Okay. So let me get my notes up so that I don't go ahead of myself. So as we know, the first thing to do is our 6 favorite lines inside of love. That's function love.load, function love.update with dt, so delta time, as a parameter. And if you guys are looking at tutorials online, there's a good possibility that you've actually seen some love.updates that don't use dt, or some people that have a mix of both of them. If you've taken level design, you've seen this idea of fixed update versus update, and it kind of works the same way. It's this idea of whether you want to go off your frame rate or whether you actually want to like have a time parameter. So generally speaking, DT is a good thing to do. So function love.draw. And you may see these flipped. If you look at other tutorials, you may see somebody using draw before they use update. Love suggests it this way, but it's not wrong to flip them around. So, okay. Now, we're going to add one other built-in function. And this is kind of a great way to say, okay, so, I know I want to get a mouse press. And there's got to be an easy way to do it, right? If you come into the wiki and you kind of look around, you can see that there's a love.mouse kind of function already built in. And you can say, okay, cool, so there's a get cursor, get position. There's all these kinds of things that are set up. Now, none of these right here are particularly quite what we want, because we want the click. We don't want it to be the position. We don't want it to be when we're not doing anything or just moving the mouse. We want it to be the click. If you come down here, we have see also. Okay, mouse pressed, mouse release, mouse move, wheel mouse. So we can come in here and we can say, okay, so, it's built in, mouse press X and Y, so it gives you the parameter or the values of where that mouse is pressed, what button is pressed, is touch, and presses. And this will kind of talk to you about it, but you know for sure that you're just going to copy this guy right here. You're not going to have to put these in. Those are going to be in there for you. And that's going to get your mouse press for you. So you can either copy it or, if you know it off the top of your head, that's great. Otherwise, copy, guys. Now, when it comes to mouse presses, key presses, those kinds of things, you can put them wherever you want. You can actually even put them inside of update. But the way that I have found them to be the best option is to put them before update. Actually, let me up my screen for you guys so that it's easier to read. And at this point, if you're still unsure of what all these functions do, write yourself a little note at the top of everything. So function love.load is going to be, loads everything for game. You only have to have 2 little dashes. I tend to do 3 or 4. Checks, mouse, presses. Updates, game, behind the scenes. And then draws all visuals. And those are just little notes for yourself. Remember, and some of you guys have seen, I've taken points off of your assignments, and it's been because I say, hey, you need to comment. You need to actually at least pretend to know what you're doing. The point behind coding, the point behind commenting, is if you go back to your code in 10 years, can you read what this does without having to look at any kind of documentation? Can you figure out what your code's doing? Or would it take you 9 million years to figure it out? If your comments are good enough, you should be able to read your code or figure out what your code was doing without having to relearn the language. Is that realistic? No, not always. But if you get into the habit of making sure that you have comments, even just basic comments, it makes your life so much easier down the line. And remember, Lua and Love don't care about spacing, so you can space things however you want. You're going to find I put a lot of extra spacing between things, and that's just so that things don't get all mushy together. Yeah. So, now we have this. Again, if we run at this point, we might get a window, but we're not really going to get, we're going to get a window, but we're not really going to get anything. Which is fine. It's all okay. And I'll go ahead and we'll fix that in a minute. So, Rumble has been running a little slow with, just about anything actually right now. With their run buttons, especially with stop. But it's manageable. If it's not manageable for you, then there's a few options. Atom, Notepad++, Site. There's a few more that have kind of a Lua and a Love thing built in. They're on their website. But this is still going to be the easiest way. Yeah. Okay. So now that we're here, we have the base of what we want our game to do. Now, the other thing that we got to worry about is we have to think about, okay, so we want images to show up. And in this case, I got my images from Kenny.nl. Most of their stuff is free. The mass majority of their stuff is free, and it's free to use. It's free to use without credit. It's free to use. And I use the tank pack, wherever their tank pack is. It's probably a few pages deep. Tanks. So, but you can use whatever you want, and I probably, in, retrospect, should have used something different other than barrels, because, barrels moving across the screen is super menacing, right? The idea was to kind of make it like an endless scroller that you were going down, but without a background, without showing extra stuff. It just looks like weird barrels advancing on you. So, but this is what I got, and I pulled a couple of these out. I pulled this big explosion, I pulled the bullet, and I pulled the barrel. But you can use whatever you want. Yeah. So I have all these here. I'm going to go ahead and just use this. I have them in a downloaded document too. This is the folder version to pull onto the love icon. So if we come over here and I open, oh cool, so there we go, that's all of them. I remember where I put stuff all the time. Yep. And if we grab these guys, all we're going to do is we're going to drag them into this panel over here. If you're building it in an actual editor, an actual IDE, you're just going to drag them into the folder with your main.lua file. So this will give me access to all these images to be able to use them. Inside of REPL, you can 100% change their names, or you can leave them alone, whatever works for you. I was lazy and left them alone, but the reality is if you're not going to have multiple types of explosion, or if you're not going to go back and animate it later down the line, you may switch this over to explosion. If you're not going to have multiple barrels, you may just switch it over to barrels. It depends on how you want to do it. You do you guys. So the next thing we need to do is, now that we have these images, we actually have to load them, because we've seen Love can't use images unless we've loaded them. So we can't call down here these guys. We have to load them first. We have to give the program access to them. So we're going to write, we're going to create kind of variables for them. So we're going to say the first two that we're going to use, because we're going to worry about the explosion later, is bullet image. Remember, you want to name your variables things that make sense to you and make sense to others. Well, really make sense to you more than anybody else. So love.graphics, because we need to get the graphics portion of love. And what do we want to do? We want to add a new image. And then we just have to tell it what the name of the new image is. So we can say tank underscore bullet 1. And remember, you have to have your extension. And then for the barrel, we can say barrel image equals love.graphics.new image. So the same way we just did that. And we'll say tanks underscore barrel green.png. If you want to test that these have worked, that you have put these in correctly, the easiest way to do that is go ahead and do a draw and say, okay, so what do I want to do? Love.graphics. Well, I want to draw, but do I say draw or do I say something else? If you're not sure, one, you should have, I think you guys have a program that you've drawn an image before, because we talked about it. But also, again, you can go to the wiki if you want. But yeah, when it comes to actual images, you just use draw again. And inside, you do, for as far as parameters, the most simplest parameters is to say bullet image, comma, 0, comma, 0. So there's a bunch of overloaded functions. There's a bunch of different versions of this. So sometimes you'll use just the 2 parameters. Sometimes you'll add more parameters for things like rotation and scale and things like that. But you don't have to. This is the simplest version that you need. And when we click run, you can see we have our bullet up in this top little corner here. So we know that that one works. And we can say, okay, so we know that one works. Let's go ahead and make sure that barrel image works as well. And this is something that you should be doing pretty often, is running your program. You should be running your program and making sure that things are working. Because nothing sucks harder than having to go back and figure out where an error is. Like, nothing is drawing, you have 200 lines of code, you haven't tested, and you're like, okay, well, where is the error? Especially when it's not something that's a syntax error, so it's not something that's like wrong with the language. It's not something that's giving you an actual error screen. It's something in the logic that's caused a problem, and you have to figure out where the heck it is. So test, and test often. And so now we know that these work, though. So we know that they show up. Now, one of the weird things inside of Love is that scaling doesn't work well. Scaling works. It looks nice. But when you're talking about collision and getting the actual kind of dimensions of things, it retains the old information. So it retains the original sizing of stuff. So if you can, always scale your images to what they need to be outside of the program rather than having to do it inside. It'll save you a lot of heartache in the long run. So, the first thing we're going to do, now that we have this done, is we're going to go ahead and add a few more variables. And there's a lot of different ways to do this, and if you guys look up tutorials, as I'm sure most of you will, you'll see lots of different ways to do this and lots of different opinions on how to do this. The way I like to do this, because basically what we need to do is eventually we need to know the X and Y position of the bullets and the X and Y positions of the barrels, because we need to be able to manipulate them, we need to be able to spawn them in random spots, and for the bullets we need to be able to like say, hey, yeah, you know, start this bullet here and move it. You could do this in one table, you could do this in a few different variable ways. The way I like to do it, because I think it makes sense and is easy for people to understand, is to make two tables for each thing. So bullets X, which is an empty table right now, and bullets Y, which is also an empty table. So all this is going to do is it's going to hold the X value of our bullets and the Y values of the bullets. And what's going to be nice is, you know, the first bullet that spawns is going to be at 10, 12. The second one is going to be at 20, 22 or whatever. But the index is going to match. So all we have to do is say, hey, yeah, look at bullet X1 and look at bullet Y1, and that's going to give us the full coordinate system for our bullet. Again, if you don't like this way, that's fine. You can do it however you want to do it, as long as it works. Again, I'm making notes to make sure that I can come back and know what everything is. And I know the cheater way to do this is to do it after you have all of your code written. I'm not gonna lie, I do that pretty often too. But commenting as you go is technically the smarter way, because it also helps to reveal any kind of logic errors that you have. So if you're coding something, and we'll see that when we get down to collision, when you're coding and you think your function should be doing one thing, or that your code should be doing one thing, but it's not, it's easy to check when you're looking at your comments if you kind of commented out the logic that's making things work. So barrels X, again, that's going to be an empty, and barrels Y, that's also going to be an empty. If we only had one of these, we wouldn't have to make it an empty table. In fact, we technically don't have to make these tables at all. We can just call them by the name. We can even just say, you know, empty object. And Love will be like, okay, I know that's a variable. I don't know what you want me to do with it yet, but I know it's a variable. That being said, this is improper if you're going to just have something that you don't know. You know it needs a name, but you don't know what's going to have in it yet. The proper way to do that is to say equals nil. That way it's given a value before it starts. And, I mean, calling nil a value is a little bit weird because it's basically a non-value. That's what it says. It says, hey, this has nothing in it. It's just, you know, floating listlessly in the stream of memory. But that's the best way to do it if you know you're going to use something but you don't want to actually give it a value yet. If it's tables, you can do it this way. But otherwise, yeah. So, now that we have that done, we can go ahead and worry about the mouse press. Because for some people, and for a lot of people, the first thing you want to get done is your movement or your main mechanic, like, really well. So if we were doing key presses, yeah, we'd get our key presses. We'd make sure that, you know, when you press the A button, you had a print statement pop up saying, yeah, I pressed the A. Or if you were trying to, you know, move up and down, you'd have that kind of same thing. In the same way, we're going to check our mouse presses, or we're going to get our mouse presses working first before we even add kind of images. So with mouse press, we have this idea of button. And button 1 is equal to the left click, 2 is equal to the right click, and 3 is equal to the middle mouse click. So all we have to do is a handy dandy if statement and say, hey, if button equals 1, then, and remember, everything always has an end statement. And then all we're going to do is we're going to say, okay, so what do we want to do if we press this button? Well, to begin with, we can say print clicked. And then we can run it to make sure that this actually works the way we think it does. So you can see it's clicking down here in the console printout down here. It's saying, yeah, you're clicking. I get that. And if we right click, so if we clear it out and we right click, it's not going to do anything. We center click, it's not going to do anything. The only time it's going to do is when we press the left click button. And so now that we know that works, again, this is about testing as we go, we can say, okay, well, what we really want to do instead is we want to get that x and y value. So we have these variables, or we have these parameters x and y, and these are your mouse presses x and y. This is where you're pressing. So you can say, okay, so instead of saying clicked, how about we do print x, and then print y. You could concatenate these and put them on the same line if you wanted to, but for simplicity's sake, we're just going to do it this way. So, are we running? Are we not running? Okay, there we go. So you can see 2822, 422.94. So we're getting our values like we want to. So now we know how to get access to our values. Because the whole point is to get those bullets to spawn where we click, and then eventually to get them to start moving. So, how do we put these values into here? Well, all we need to do is add to the end of our table with the new values. So, the first thing we can say is give ourselves a comment, store the bullet locations, restore the clicks in the bullet locations, or however you want to put that. So to do that, we say, okay, we want to take bullets X, and we want to access whatever the last element, so the last thing that exists, and then we want to go one ahead, so we want to add a new element to the end, and then we want to set it to X. Now, if you guys have looked at tutorials, there are older ways to insert at the end. There's a few ways that have been deprecated, and there's a few ways that sort of work but aren't suggested anymore. The way to access the length or the end of your array table is actually to just do the pound sign, number sign, hashtag, whatever you call it, the name of your array, and that gets the length. That gets you to the element that's the last one. And remember, tables are weird in Lua because they start at 1, which means when you guys did Java and stuff, you're used to saying, oh, I gotta do, like length minus 1 to actually get to that last element's name. You don't have to do that here. So all we have to do to get to the last one and then go to a new one after the last one is to add a 1. So right now, this reads, on this without having anything clicked, this reads as 0. So we go to 0 plus 1, which is our first element, and that's where we want to store our information. If we already had that one, this would read a 1, and so we'd go to number 2, then number 3, number 4, etc., etc. And so all we have to do is say equals x. And the same thing for y. So that stores the clicks at the bullet location. Now, if you want, at this point, you can test it. You can say, okay, the same way that we just printed, but you can do that. You can print bullets X, hashtag bullets X plus 1, and the other one if you want. So if we run it at this point, you can see, we're getting a nil value, which is not what's supposed to be happening. Why am I getting a nil value? What did I spell wrong? That's why we test. Because that should actually be popping things out for us. If bullet 1 equals X. Huh. Bullets. Okay, so it is getting the length. It's just deciding that it hates me. Oh. Is that what I did? So if you're in REPL, there's a possibility that it just won't work at all right now. Alternatively, it may be the browser that you're in. So if you are on Chrome, if you open it in Edge or Firefox, there's a possibility, like if you press the stop or start button, that may be the thing, or you may have to code it outside. It just depends. Okay, so what I did, like a dumb person, is I, again, this is where logic comes in and why I should not be coding at 9 in the morning. I was extending past what we had. Where this logic is where we store the next one, this one needs to be, you know, what the last one is. So, as far as REPL not working, there's either just refreshing the crap out of it or trying to open it in a secondary browser. Just going along with the flow and deciding that that's just not what's going to happen today. Okay, so now we have the right thing printing. So okay, I deleted it because we don't need it. You can have it if you want it. It's just going to clutter this down here down the line. So now that we have this here, let's draw the bullet at the point that it's at. So down in draw, we can say, okay, we want to make sure that before we go to draw any bullets that those lists actually, or those tables actually have stuff in them. So we can say, hey, if bullets X, if the length of bullets X is greater than 0, then we want to draw everything. And to do that, to draw everything, we're going to use a for each loop. I've talked about these a few times, and I said that they're wonderful, but they're also a little confusing. So the way that they're written is for I comma v, and I and v can be any, these are just your variables. In this case, they call them index and value. You'll see later on I'll use like A, B, C, D. These are throwaway kind of counter things. This is the only time that I'm not angry at y'all for using single letter variables. And remember, we can say, hey, this means if any bullets exist, draw bullets. But so for IV in I pairs, because we haven't given the index names, we've left them as just the single values so they can be called by 1, 2, 3, 4, etc., etc. Then we have to give them what the name of that is, and in this case we're going to use bullets X, do. So we have to say, okay, what are we doing for each of these in bullets X? Now, why aren't we calling bullets Y? Well, we could call bullets Y if you wanted to instead of bullets X. The point is that they're the same length because what we're doing is we're calling them, you know, they're a pair. They're a matching pair. They should have the same length unless you've done something really wonky. So we really only need to look at bullets X to get kind of our length and to go through that table to say this is the beginning and this is the end. So all we have to do is we have to say, again, we've already done this, love.graphics.draw. And what do we want to draw? We want to draw the bullet image. And then we have to give it the X and the Y value. To do that, we use bullets X and the index that we're currently on in our loop. And it will occasionally say that. It still opens. So could not open device. It gives you that. Again, sometimes it's a matter of which browser you're using, sometimes it's a matter of REPL just not working, sometimes it's a matter of your internet is and your memory is having to do too many different things, so it's just not going to work. Like, the option if REPL's not working is to download or code in something else. That can be Notepad, that can be Notepad++, that could be Cited, that could be Simplify, that could be any numbers of things. If you go to love2d.org, you have to download actual love, but you also come into the wiki. There will be a getting started button, and they will talk about Zero Brain is not free. It's like $24. Don't get it. Sublime Text, Notepad, Cited, IntelliJ, Atom, they all have add-ons for Love and Lua. And it just depends on what you want to do. So basically, if you're going to do it this way, you'll code in whatever coding you want. You'll put them all together in a folder. And to see if it's working and running, you'll grab the folder and you'll drop it onto your love icon, and it'll run the game. Like, that's... If REPL's not working, it's either just not your time to work in REPL, or you gotta find a different workaround. So, again, we're drawing this idea of the bullets. And we're pulling from the index. So this will go through 1, 2, 3, 4. So what's the value at bullet X1 and bullets Y1? What's the value at bullets X2 and bullets 3, etc., 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 so on and so forth. So now it means that it should as it stops. Oh, okay. So, again, this is why we test. Syntax error. Line 38, then expected near the for line. So, I used for, or I used do instead of, oh, here. So, again, if statements, when you guys are used to other languages with if statements, you're used to not having to write the then. Here we do. So, again, that's what this says. Okay, and then expected near the for. So, there's a then or something missing near this line. A lot of times it means, if you're looking at that, it's that you forgot it at the last kind of loop, or the last conditional statement. So now, you can see when we click, we have bullets spawning at the points that we click. They're not moving, but they're spawning. And that's all we really wanted to do at this point. Just get them to show up on the screen. That's it. So cool. So, now let's make a move. We can go into update. And if you wanted, you could give a bullet speed outside. You could give it in load. You could give a base bullet speed. I'm going to hard code it, which is not always the best idea. But since this is only going to be accessed in one spot, nah. Again, if you want, you can do if the length of bullets is greater than 0, do this thing. But it works if you don't. So we can say for I, comma v, again, because this is in a different function, it's not like the worst thing in the world to call this again. You can call it multiple times. As long as you're not looping inside of each other and calling it, it doesn't cause problems. In I pairs bullets x, so exactly like what we did with the drawing, we're going through each of the indexes that exist. And what do we want to do? Well, we want to take that x value, because we want to move on the horizontal, and we want to manipulate it. So bullets xi is now going to equal bullets xi plus whatever speed we want. In this case, I think I end up, what do I end up at? Let's see. Or let's not see. That's probably the reality here. Because I know I started with 2, because 2 is a great place to start. Oh, I guess I stayed at 2. Okay. Oh, now I scrolled way too far down my notes. Okay. So, we'll just do plus 2. Now, you could do 2 times dt if you wanted to, or you can just do it this way. So, we can run. It's going to say, okay, so there's a nil value. I can't do this because I don't actually know what this is. And you can also tell that I wrote this wrong because it's not blue. So it's not a recognize. It needs to be I pairs. Or, okay, yellow. Again, I've said this about 100 times. I do this on dark for y'all. When I'm actually coding by myself, I don't do this on dark. So I can never remember what color anything actually is supposed to be. So now, oh, we have bullets shooting, and they're going, and they're doing things. Now, we run into a new problem. The new problem is that every one of these bullets that we're pressing is creating this table that's longer and longer and longer. Even if the bullet is off the screen, it's still moving, it's still going, that number's getting bigger and bigger and bigger and bigger. So what we really need to do is we need to say, hey, if it's off the screen, delete it from the table, delete it from existence. We don't want to worry about it. We don't want to look at those numbers. And we definitely don't want a table that's just ballooning into millions and millions and millions of entries, much less numbers that are so big they're starting to get scientifically notated with ease. So to do that, it's actually relatively easy. We can say inside of this loop, inside of this pair, we can check each of those bullets. So we can say, hey, if bullets x, I, because we only have to check the x direction because we're only moving in that horizontal direction. That's why we're not touching anything in the y for these, because we don't have to manipulate them up and down. If you were, shooting at an angle or shooting vertically, you'd adjust it. But right now, we only have to worry about the x's. But so if bullet xi is greater than our screen width. Now, you may be tempted to just write 800 here because you know that the screen is 800 by 600. Unless, you go in later down the line and you change your window parameters. So if you do that, then you're boned because it's only going to delete when you get to 800. Instead, Love has a built-in function to get the width of your screen. So we can say love dot graphics dot get width, and that will get us the width of the entire screen. Then end. And to remove something from a table, again, one of the nice things about Lua is that it's pretty common sense. It follows a pretty easy to follow thing. So what do we want to do? We want to get a table and we want to remove something. Well, what do we want to remove? We want to remove from the table. We want to remove from the bullets X table. And what do we want to remove? Which element do we want to remove? Well, we want to remove whatever's at I, because it's over the line. And then we do the same thing, and we can just copy this if it's easier for you, and paste it, and switch this over to a Y. So then, we delete the bullets X and the bullets Y. Now, when I was fast writing this last night, I actually forgot to put this one in, and I want to show you guys what it does. Because this was kind of a fun bug to be like, what's happening? And then realizing, again, this is why you test and test often. Because you want to see when things like this are happening, and it's easier to catch it early on than it is later on. So you notice how some of these bullets are moving in weird directions. They're kind of like going backwards, and they're not quite going where my mouse is saying they should be. That's because we're only deleting out of the X at this point. We're not deleting the Y. So they're actually matching with different kind of pairs. So you've got to make sure, if you do it this way, that you're removing and you're manipulating both the X table and the Y tables. So again, we can add a comment here, we can add spaces, we can do whatever we need to do. But we can say, remove bullet if over screen width. So, and you can also insert things by using table.insert if you need to insert something like in the middle of a table. But again, to access and to add to the end, you're going to want to do this way instead. Okay, so now that we have bullets firing wherever we click, we can call it a day. No. Let's get some bullets spawning. Or let's get some bullets spawning. We already have bullets spawning. Let's get some barrels spawning. So we have these barrel coordinates. And let's get one barrel going at a random place on the screen. So we have to set up randomization. And you can do this once inside a load, and then it'll have this table for you that it can go through. The alternative is that you can do it basically every time you initialize something, so in the function that we eventually make. And it's kind of up to you what you want to do. But in this case, we're going to do it inside of load. And remember, the first thing we have to do is we have to say, hey, math.randomSeed, because Lua, and by proxy loves, random is dumb, is dumber than dirt, and it has a table that will randomize at the same place every time. So we have to give it some sort of randomization. So we're going to take our clock from our computers, and we're going to use those numbers as our randomizer. So that's just os.time. And then we have to prime things. We have to set up and we have to make sure that all the old stuff, so all that old bad table, is out of its system before we actually call anything. So we're going to go math.random, math.random, math.random. This serves no other purposes than to make sure that you have nothing from the old calls and sets it up so that you can call the new stuff or call from this new random seed. You can put them on separate lines. You don't have to put the semicolons. The semicolons are nice because it makes more sense. You can see that these are separated. But it's kind of up to you and how you want to do it. So now that we have that, we can start setting up, well, where is our X and where is our Y for our barrel going to be? In this case, for the first one, we're going to have an initial load. We're going to have an initial barrel that loads up for a while. And then we'll eventually go back and make multiple barrels that are doing multiple things. So this is kind of placeholder code right now, but eventually this is what everything's going to be built off of. So we're going to say, hey, for the first barrel, and we're going to go ahead and code it the way that we've been talking about it. So if barrels is at 0, then we're going to say, hey, well, if it's at anything, we're going to say, we're going to take the length of our current table, and we're going to add 1. And then we're going to put it someplace. So now we have to think about, okay, so where do we want this barrel to actually sit? Well, we can do math.random, and we know that at its leftmost point, it can be at 0. So we can say 0. Then we have to worry about the rightmost point. So we know that that 800, because we've already seen this, we can say love.graphics.getWidth. But if we leave it at just that, there's a possibility that the barrel won't show at all. And that's because images in love, the coordinate corresponds to the top left corner. So we could technically spawn something at 0, 800, or at, not at 0, 800, at 800, 0, and it would be off the screen because that last little pixel would be, or that first little pixel of the image would be at 800. So what we have to do is we have to take that into consideration. So we have to say, okay, so how wide is this image? So that we can subtract that, so we know that, so if it's like 20 pixels wide, we know that instead of being able to spawn all the way to 800, instead we can spawn only to 780 to make sure that that whole image fits on the screen. So to do that, there's a slightly different way, but it kind of looks like this idea of get width. So we're going to subtract from the width our barrel image with a colon this time, get width. That gets the width of the barrel without you having to know it off the top of your head, which is so nice, and it subtracts it from our width. So now we can spawn between 0 and whatever will let us be all the way to that edge but showing the whole image. And now you can do the same thing for your Y. And I realize I wrote initial and then didn't write anything else. So if you want, you can write it all out again, or you can copy it because, oop, and that's actually wrong too, barrels X. So barrels Y, and we can say, okay, that's a Y, math.random, instead of get width, it's get height, and instead of get width here, it's get height. Again, for some people that's faster to write out, for some people that's faster to copy and paste. So now that we have these, again, if you want, you could print here, or since it's easy to see this visually, we can just come down here and we can actually draw our barrel. So we're going to do the same thing that we did here with this bullet thing. So what I'm going to do is I'm just going to copy this because, you know, it's the same thing. It's literally the same exact logic. So we can say if any barrels exist, and we're going to draw the barrels. And you just have to make sure that if you are copying and pasting, that you're actually, that is wrong. If you're actually changing all the variables that need to be changed. But why are we doing this like this instead of just calling the one that we know we've made? Again, we know that eventually we want multiple barrels. Because we want multiple barrels, we want to do this so that we can eventually have this. So instead of having to, you know, go back and completely write some code, because we now, instead of just drawing one, we've got to draw a bunch of them, let's start drawing a bunch of them first. Or let's start with the logic to draw a bunch of them, or one of them. So now that we have this here, we can click run, and it'll tell me if I've done anything dumb. Okay, so we have our barrel, it's launched, or it's created. And I promise it's all the way at the bottom, or it's all the way, it's not, whatever it's called. It's not, because my window is so big, it's not showing really exactly, so there, so that's a better spawn. We can see there's a bunch of spawns here. So it'll just keep randomizing where it sits, which is what we want. We just want, you know, a random barrel right now. Now, you could also actually put your barrel in one spot if you wanted to. It kind of depends on how you want to do it. I like randomizing to start with since I know how the logic works, but maybe with collision you're not so sure, so you might want to keep it in one spot and check your collision that way. But it's up to you. So speaking of collision, that is what we are about to do. Okay, so hold on to your hats because this is where things start going a little bit crazy. Now, some of you guys may have found collision libraries and collision classes, which I say classes, and there should be air quotes around that word because technically Love doesn't really do classes the same way that we think of them. And yeah, but the reality is that writing your collision isn't so bad when you start understanding the logic. Now, I am going to start with the caveat that the way that this collision works, the way that I am writing it today, the entire bullet has to be inside that barrel for it to cause a collision. Or at least, okay, not the entire bullet, but the entire height of the bullet has to be inside to cause the collision. You can change it relatively easily so it's only that center like bullet point that needs to be touching it, or only part of it. But in this point, what I'm going to show you is like if you were body checking it, you want to make sure that you're colliding correctly. So we're going to do it above this kind of Okay, hello, cat. Bullet movement. We're gonna do a collision check. So what we're gonna say is we're gonna say check for collision between barrels and bullets. Now, you 100% could do it down here in this IV, but it's not always the best idea to do it, and it's really not going to add enough load time for you to care to do another set of loops here. Maybe if you got down the line and your game was like giant, yeah, but we're going to be okay. So we know what we have to do is we have to go through the list of barrels. And so for each barrel, we want to check, hey, has a bullet hit me? So we also have to go through the list of bullets for each barrel. In this case, we're going to do nested for loops. So that's where you do a for loop inside a for loop. So we're going to say for AB. Remember, this is just your index and your value. You can call them any name you want. In I pairs, barrels X, do. And again, I always write that in statement because otherwise I forget about it. And then our internal loop is going to be for C, comma D in I pairs, bullets X, do. So what this is going to do, again, is for each barrel in the list, it's then going to go through each bullet that exists and see if collision has happened. So, the logic behind this is we want to check if the right edge of the bullet is greater than the left edge. So has that right edge passed that left edge of the barrel yet? If so, then collision might be happening. But we also want to make sure that the left edge, so the end or the back of the bullet, is also, you know, in the right place. So we want to make sure that it's less than the barrel. So we want to make sure that the x's are, the x value of that bullet is somewhere contained kind of in the barrel. And then we also have to do that for the y values. So we have to say, okay, so, how do we want to do this? We want to say, well, is the bottom of the bullet less than the bottom of the barrel? Because remember, this is 0 up here, this is 600 down here. And then our last little bit of logic is we have to look at the tops. So we have to say, hey, is the top of the bullet greater than the top of the barrel? And this is where pseudocoding really comes in handy. There's going to be another point where I actually got out a piece of paper and had to draw it out the other night to figure out exactly how I wanted to do the calculation. So pseudocoding is great. This is another place where you can check your logic, and your logic may or may not be valid at this point. But it helps you when you're having to write this. So what we're going to do is we're going to write a big, giant, beefy if statement that has all 4 of these things. So for collision to be true, we want all 4 of these options. So we're going to use and statements. So we're going to say if 1 and 2 and 3 and 4, then do the thing. So the way to do this, to not lose your mind about it, is to write each of these on their own line, basically. So we're going to say, hey, if bullets x, so we're checking the x value of the bullet, and we need that right edge. Well, first off, we know for sure that we're going to use C because we're going to use it in that first index, or in whatever that index is for your bullet. So if bullet x, and again, we want the right edge of our bullet. So we want that edge that's the furthest away from what our point is at our origin. So where we have our bullet, if it's spawned here, you know, we need to get not this point here, we need to get this point. So we have to add the width. So if we can say if bullets x plus c, or if bullets x index c plus the width is greater than that left edge of the barrel. So we don't have to do any kind of extra addition there. We can just say barrels x a, because remember, we're wanting to get this barrel, this bullet, this barrel, this bullet, this barrel, this bullet. And remember, because Lua doesn't care how you space, we can actually get these to be all nice and kind of neat. The next one, so the left edge of the bullet, so we know that that's bullet x with index of c, with nothing added to it. We just need to get that left corner. And we said, okay, if the left edge of the bullet is less than the barrel, so we know than the right barrel edge. Yeah. So we know that we need to say, okay, so is less than barrels x a plus, again, our barrel image get width, and now we're going to switch over to our y values. So bullets y c plus, remember this is going to check the bottom of the bullet, so we're going to say bullet image get height, and now our logic says bottom of the bullet is less than the bottom of the barrel. So to do that, we're going to be less than barrels y index a plus barrel image get height and the last one is the top of the bullet greater than the top of the barrel. So that one's the easiest one to write. Bullets y c is greater than barrels y a. So after this, we got to make sure that we have that then. And we want to make sure we also have our end statement. And in this case, just to make sure that it's firing correctly, we're going to go ahead and we're going to say print init. Now, 100% there's a good chance that I mess this up, because this is literally probably the easiest place to have this mess up. So you can see it's not actually firing. It's not giving us, oh, it may actually be firing in it. So, okay, so it is. I did it right. Yay. So you can see it's only firing when we're inside, and as soon as we're outside of it, it doesn't fire. So if we clear and I fire up here, you're going to see it doesn't, you know, it doesn't do anything. It doesn't do anything. And even if just like the top of it scrapes it, it doesn't count. It has to be completely inside the barrel. So that's how, in its most simplified state, collision can work. This doesn't mean that it's a solution for everything as far as collision goes, but you can get collision working pretty well using something like this. And it's just a matter of being able to see the logic. And that's one of the reasons, because I know you guys, why the heck did I have you pseudocode so much? Why am I making you do that? I'd rather just code it, or I'd rather not code anything at all. The reason why is because understanding your foundational logic will save you heartache in the long run. Because without writing out exactly what you wanted, trying to figure out collision, there's a good possibility that the first thing you did was like, okay, let me go Google how to do collision, and let me go find some sort of strange library that I don't really understand what it's doing, but it says collision. It's much better if you can figure out the logic on your own. So, now we technically have this working. And there's a couple things we're going to add in here, because we're going to see that I actually don't check to see if there's nothing in that kind of thing. And there's a few places where this is going to cause problems down the line. But we're going to leave it alone until we get there so that I can show you what we're talking about. Now that we have this working, now that we have collision, the one thing that we included over here that we haven't really touched yet is this explosion. Ideally, we want the explosion to show up when the bullet hits the barrel. That's everything we want it to do. Nice and easy, right? So, we can come over here up into our load where we have everything else loaded. And up here where we have our kind of image bank that we have. And these don't have to be in this order. I like putting all of my images that I'm loading in one spot, only because it's easier for me to find them. And we're going to do explosion, what do I call it? Yeah, explosion image. I'm going to say equals love.graphics.new image. And we just got to make sure that we spell everything right. Tank underscore explosion 4.png. So now we have our image. And the next thing we have to do is we have to say, okay, well, and again, this is just because these are in this order. I'm going to go ahead and add the explosion stuff down here. And to do this, we're going to do the same thing that we've done with everything else. We're going to have an explosions X. We're going to have an explosions Y. And we're going to add one more that we're eventually going to use. Explosion timer. Now we're going to use explosion timer eventually so that we can have the explosion show up and then eventually disappear. Now, you could also use this timer down the line to fade the explosion out if you wanted to. I'm not going to show you how to do that. It's just a matter of changing the alpha channel, which you can do by looking up how the graphic display works. So, now that we have this set up, we can go ahead and create the explosion at the tip of the bullet. Now, what we're going to do is we're going to do it here, where we have this whole idea of print it. We have to make the explosion. Now this is where I actually had to draw things out to figure out exactly where the tip of, or where the explosion was going to be. Because the reality is that you don't want to put the explosion at the coordinates that is the bullet, because that's the back of the bullet. And you don't really want to put it at the front of the bullet or at the bottom of the bullet. You want to put it at that tip of the bullet. So you have to figure out this idea of half of your height of your explosion plus the tip of, or the width of your bullet. Yeah, so there's math involved. There's not a lot of math, but I literally had a napkin out and drew it last night to make sure. And that's the same idea as pseudocoding. It's this idea of planning beforehand. If I'd been smart, I would have taken a picture for you guys, but no, I was not. So you're just gonna have to trust me that my math works. So we're gonna say, okay, so if a bullet hits a barrel, we want to create this kind of, so if a bullet hits a barrel, we want to create the explosion. So to do that, we have to, put the X at the X place and the Y at the Y place. So we're going to say explosions X. And we're going to do, again, our favorite, add it to the end, explosions X plus 1. And then it's going to equal bullets C, which is the bullet that we're currently on, plus the bullet image. Oh, that is not a plus sign. And get the width. And then we're going to subtract from that so that we can move it over to be the explosion to be centered on that tip. And you don't technically have to add parentheses, but it helps me understand and it helps me see things. Explosion image, get width, divided by 2. So that's going to give us the X value. Now the Y value follows similar logic. We're going to say explosions Y. And again, number explosion Y plus 1 to get to that end thing, or that empty after the end, equals bullets C plus, well, not plus, minus, right? No, plus. I'm right. Forget I said anything. Plus. And this one's going to get a little bit weirder. This one's going to be bullet image, get height, divided by 2, minus explosion image, get height, divided by 2, and that should be good. Now, while we're here, we're going to go ahead and put the explosion timer up. Not that it's doing anything yet, but we're going to say, while we're here, we might as well. Explosion timer. We're going to say we want this for technically 2 seconds to start with. We're going to say number, explosion timer plus one. And I'm going to hard code it again. You can put a timer variable up top if you want. Hard coding is not your best thing. So the one other thing we want is when we want this explosion to happen, we want the barrel to disappear. Makes sense. It's been blown to smithereens. So again, while we're here, we can say, hey, table.remove. And we want to remove barrels X, or from barrels X, we want to remove whatever's at A, so the current one that we're on. And then table.remove number, or not number, wow, tails.remove barrels Y, because remember they're a pair, so we got to make sure that we've got them, and at A. So now we technically have the logic here, but we're not drawing anything yet. So we need to draw the explosions. So down here, exactly how we've done all of these others, we can go ahead again and copy this. And we can say if any explosions exist, and we can say if explosions X, draw booms and this is just, you know, subbing out values. Okay, cool. So now we technically have the logic, if I haven't done anything wrong. And you can see occasionally, like I said, this loads and breaks, because why would it not break without it actually being broken? You gonna let me run again? Okay, so when we hit the bullet, when we hit the barrel, you're gonna see, there's an issue. I've spelled something or misdone something. So this is gonna say, hey, at 57, I haven't added that extra Y value that I was supposed to. So we can come down to 57 and we can say, okay, what did I do here? Okay, we have, oh, bullets. Okay, yeah, that makes sense. For this one, we need bullet X. For this one, we need bullets Y. And that's, again, that's just a me error. That's not something that it will catch every time. Because the way that Lua works is like, yo, you have this random new variable. Awesome. I love it. It doesn't see it as a bad thing, like, say, Java or C++ would. So now we actually have it working. See, we've got our explosion cloud when we hit the barrel. So again, boom. Life is good. It's doing basically what we wanted to do. Now, the next thing is we can create this kind of super simple timer to get the explosion to disappear after a while. Because if you think about it, if we started exploding a bunch of these barrels and those didn't disappear, you'd end up with a whole sea of orange. And because they get drawn on top of the barrels, eventually you wouldn't be able to see any barrels under all of the orange. So to do that, we're going to use our trusty dusty friend DT. And what we're going to do is I'm actually going to come in here and we're going to come into this one that we have already. And we're going to set this to, well, let's leave it at 2 for a while. And now we have to kind of make the timer count down. So we can come down below everything down here. And we want to make sure that we're outside of everybody else's loop. So we're going to be right before this end. And we're going to create another for each loop. Again, for each loops can be very expensive because you're going through each thing. But sometimes they're exactly what you have to use. So again, we're going to create some new variables just to make sure that we're not, messing with anybody else's IV, A, B, C, D. And we're going to say in iPairs, explosion timer do. Remember, always add that in statement, otherwise you will forget. And we're going to say explosion timer E equals explosion timer E minus dt. So what we're saying here is we're getting real time. We're saying subtract how much it's taken between frames and update. And just to make sure this is working, we can go ahead and we can print explosion timer E. So when we run, oh, there's a nice dog. Good job. There's a barrel down here. Okay, let's respawn that barrel. This is the only problem with making this bigger, is that then it causes problems when we're running. Okay, so that should work. So now we're going to see when we run this and we hit this, we've got this timer going, and it's just keeping going. But we have a timer, and it counts down, which is what we want. So now we have to say what to happen after we, get to a point in the countdown. So when we get to 0, what do we do? Well, when we get to 0, we want it to explode. Makes sense. So we can go ahead and comment this out, because otherwise this is going to print forever in 6 years. And we can say, okay, so while we're in this, if explosion timer E is less than or equal to 0, because there's a good chance that you won't get exactly to 0, but you want to make sure that if you manage to actually be on 0, that it'll also do it. Then we want to remove the explosion from the tables. That's it. It's nice and easy that way. And we can say table.remove. What table do we want? Explosions X. And at the value of E, table.remove explosions Y at the table, or at the point of E. And then we also need to make sure that we're removing the timer as well, because it's over with, so delete it. And so now, when we run this, we may actually run into the error at this point. 1, 2, 3. Okay, I guess I probably already fixed it. So you can see, now after 2 seconds, that gets removed. Cool. It was that easy. Now, again, if you guys go out and find tutorials, they're going to have you make a much more complicated timer. Are there better ways to make a timer? Yes. And are the more complicated reasons done more complicated for a reason? Yes. Does this 100% work for what you need it to do? Yeah. Does this make more sense than things that have lots of dot operators and other variables? Usually, yeah. This is simple logic. Remember, a lot of game development and a lot of everything, it's based on logic. It's based on simple
If something's happening, do this other thing. While this thing is happening, do this thing. If this thing is happening, don't do this other thing. The problem with things like Unity and Unreal is you don't have to think about that logic as hard as you do with something like that. So that's a thing. And this really kind of forces you to think about that. And it will make you stronger programmers in the long run as far as having to think about this logically. So that's one of the reasons why I actually like this class for teaching this. I mean, I love this class, don't get me wrong, but I know a lot of you guys look at this class as, I'm never going to use this stuff. Why do I need it? And the big point is that it's trying to get you guys to think about these kinds of things at a base level. So we want to delete the timer and explosion at 0. Okay. So, one thing that's still happening though is you hit and the bullet still goes through. Not really what we want to happen. Not how bullets really work, right? We want the bullet to go away. So we have to delete the bullet as well. This is where you can actually find an error. So if we do this without there's a small error that's like, because we're doing these loops, you can delete something and it's still trying to access that variable. So you have to make sure that you're checking. So we have to add a loop here. One more if statement. I say a loop, but it's an if statement. So we have to say, hey, so before we check for the collision, we want to make sure that both that barrel and that bullet that we're checking still exist. So we're going to say bullets X, C, and barrels X, A, then. And remember, all this is saying is, hey, is there a value in this stuff that I'm calling? If there's a value and it's not a nil, it'll let me go on and do the thing. Otherwise, it won't. So we're going to go ahead and we're going to tab this over so that it's inside that loop. Again, you don't have to tab, but tabbing helps you find things. And we're just going to have another end down here. So that's the first thing that we have to do. We have to make that, because otherwise you will run into a point where, because this doesn't exist, it's still checking against things, and bad things eventually happen. So we have this idea that we're removing the barrels here. And we have to do the same thing for the bullet. So table remove bullets X, comma C, and table dot remove bullets Y, comma C. So that removes the bullet when the explosion happens. So now, wherever the heck the frickin' barrel has decided to be, the bullet goes away and it's just a nice explosion. So it's starting to look like, we've got a major mechanic. You shoot the bullet, it explodes, the bullet disappears. It's the start of something. So now that we have this, why don't we go ahead and make a few, 5 barrels. Let's make some barrels. So we can edit this right here to automatically give us 5 barrels. Now remember, eventually we're going to see that this is why we want to have a function, because we're going to start putting this code everywhere. But I'm going to do it how you guys will probably think to do it first. And it's not the wrong way to do it. It's just once you start noticing that, oh, I'm writing this same exact code a lot of times, that's when you probably want to make a function. Because it's easier when you have to go back and edit, to just edit one thing instead of having to find everywhere you put the thing in. So in this case, we want 5 barrels. So we're going to give a count of 5. We're going to say, hey, while count is greater than 0, do. And we're just going to do this. So now, when we press run, unexpected symbol near. Oh, it helps if you add the variable in. In REPL, the blue screen is much, much more helpful than whatever it's doing down there. Okay, we're gonna actually. Ooh, that's fun. I've never seen that. Okay, so the reason why this is happening. Did you catch what I didn't do? We have this count. And the count is greater than 0. But nothing decreases the count. So right now, we're just drawing barrels on top of 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 barrels. And it's overwhelming the system. So remember that if you're going to do counts like this, you always have to make sure that count equals count minus 1. So some of you may be asking, well, can we do count minus minus, or couldn't we do something like that? Lua doesn't have the same set of shorthands that other languages do, so we've got to do it the long way. So now we have 5 barrels. Yay! Wow, we can shoot 5 barrels. We can shoot barrels. And it works. You know, it's a thing. It's actually looking like something. Yes, I know, in Unreal or Unity, you're like, I could have done this in like half an hour. Why have we been sitting here for an hour and a half doing this? Again, this is to get you to understand the basics of how this all works. So, how about we have a new barrel spawn every 2 seconds? After this while loop, we can add a barrel timer and have it set to 2. And then we can come down into this area where we have our timer already set up. You know, we might as well put it down with the timer loop, right? So we can say, okay, we want to make a new barrel, so it's outside of this loop, but it's still in these timers. So we can say, if barrel timer is less than or equal to 0, so just like we did with the last one, then, and what do we want to do? Well, we want to create all this stuff that we have up here. So, you know, once you start finding yourself copying code like this is when you have to start thinking, oh, you know, maybe if I did this as a function, this would make more sense. But for now, we'll put it there. And if it's less than 0, we also want to reset the timer. So we're going to say barrel timer equals 2. But right now, nothing's changing the timer. So we just say, okay, so if it's less than 0, we want to do that. But if it's not less than 0, we want to do something else. You could just say an else statement, but in this case, to make it explicitly clear what you're doing, we can use else if barrel timer is greater than 0, then, and what you do here is you can say barrel timer you can say barrel timer equals barrel timer minus dt. So we want to take the timer that we have and subtract whatever the frame change has made, so the time that's taken between the frames. And that'll get our timer counting down for us. So now, if we run this, you're going to start seeing there's a barrel down here. Another barrel popped up, another barrel popped up, another barrel popped up. Now, of course, what this doesn't do is it doesn't check if a barrel is occupying the same space as another barrel. You could change the code to do that. The logic's not hard to do that. But that's on you guys. This is me, I'm just showing you basics. I'm just showing you how to get around this. So you can see we're like endlessly spawning barrels. And we can endlessly shoot all of these barrels. And yeah, again, the other thing is that you could just like really spam the left click and obliterate this game, but you could also put, you know, only 5 bullets can be on the screen at one time, or you have to have an ammo kind of, or like a reload sort of thing. There's lots of things you can do, but for now this is basic, and this is what I want to show you guys. So now we've got lots of barrels spawning. Okay, so let's add another barrel that spawns when you destroy another barrel. Now at this point, before we actually add that in, this is where it's like, okay, we've copy and pasted this enough times that this deserves to have its own function. So what we can do is up at the very top before load, or really wherever you want to put it, but I tend to put functions that I've made that are like specific to doing other things at the very top. We can create function barrel spawn and then what we can do, and again, a lot of times when you look at functions, you would have parameters here that was like the barrel X, the barrel Y, the barrel image, the width, the etc, etc. And yeah, that's technically a better way to do it. However, we know that this is going to be used and that this is exactly what we're using. So yes, this is hard-coded, and yes, this means that it won't be as easily usable for other kinds of things. It's not as fully functional. But this works for us. This is what we need to do. So instead of writing these it's technically 2 lines, these 2 lines of code out every single time, we can just say barrel spawn. And then we can come down here and say barrel spawn. And then where we were going to add it when we had this explosion happen, you can just add barrel spawn. Like, you know, what's the point of having to rewrite that like 800 times when instead we can just say barrel spawn. And you can kind of say wherever you want to put the barrel spawn here. We can just put it at the end. Oop. So now when we run it, you can see our barrels are still spawning. It's still doing exactly the same thing that we had it doing. And when we hit it, we automatically have another barrel pop up that's separate from our timer. So now we're getting more hectic. We're getting more things on the screen. This is starting to look more like something that could turn into a game. So, the next thing to do, and the next thing to think about doing, for me, would be to get the barrels moving. And that's because, okay, at this point you could just have it where it's shooting things. But when I originally envisioned what this was going to be, I was going to have a little tank and it was going to shoot the barrels and it was going to be like it was moving across the screen. So we're just going to go with that. Yeah, the barrels look super menacing walking across the screen. But you could switch it out with other things, or you could actually add that tank in and make it better. So what we're going to do is we're going to have, down where we have this barrel spawn and this count, 1, let's go ahead and get rid of that. And this barrel timer, we're going to go ahead and add the speed. And in this case, I know it's going to be like 25, so I'm just going to put 25 in. And that's because I actually multiply it, or I multiply it by dt to make sure that it's moving at the right thing. So, just like we did with this kind of movement for the bullets, this bullet movement here, so this line right here, we're going to do the same thing for our barrels, only we're going to move them in the opposite direction. We're going to move them towards the left. And what's nice is because we already have this loop right here, we can actually include it here. So we just have to make sure that it's not inside this loop. We have to make sure that it's outside of that loop right there. So we have to make sure that we're inside this loop and inside this function. So we know that we can go between right here and we can add our movement code. So we can say barrel movement. And we can say, hey, if barrels x a, if I spell barrels right. So if this exists, if that hasn't been deleted for whatever reason, because it exploded. Oops, no, I lied. That goes one more outside. Does it? Yes, it goes one more. I lied. It goes there. Again, this is why counting and looking at where all of your in statements is a good idea. And this is also where tabbing helps you, because I know that this ends. And the other way to help, if you're in REPL, if you come up to most, if you come over to these numbers, you can actually collapse things so you can see where they actually are. So you know that you just need to be in this one so you're in the right place. So if barrels x a, so if it exists, then cause it to move. So barrels x a equals barrels x a minus barrel speed times dt. So now, when we come over here and we run, you can see they're slowly, menacingly moving. And you can speed them up, slow them down. You could also, if you wanted to, make another table and have them randomize the speed. Just food for thought. But one of the things that's kind of weird here is that we have these barrels that are randomly like popping up in the center of places, right? They're always spawning in kind of weird spots, like suddenly appearing out of nowhere. And the reality is, if we were on kind of a runner situation, it would be coming off of that right side of the screen, and it would always be going off. It wouldn't be appearing randomly. So, to fix that, and the reason why we're going to go, yay, I'm so glad we put this in a function, we can change these settings, and it'll change our spawns for everybody. So, what we can do is we just have to say, okay, we want, for the X, and we don't have to change the Y at all, we just need to change the X. We want the minimum to be the edge, and we want the maximum to be whatever we want it to be. It could be 1,000 off the screen, it could be 100 off the screen, it can be whatever you want. In this case, I'm going to do love.graphics.getWidth plus 100. So the barrels can now start at between 800 and 900. So 100 pixels off the screen. They've got kind of that sweet spot, so they look like they're coming off, or they are coming off of that right side of the screen and coming onto the screen. And that's it. That's how easy it is to fix that, and that's why having functions like this, if I write things correctly, get width, because I probably didn't make that yet. If you get that and you're doing this, 9 times out of 10 you've forgotten the parentheses. But so now, they're not initially on the screen, but you can see them coming off this edge. And this looks much more like it could actually be a endless runner or some kind of that kind of thing. It's the same kind of idea if you were to do it vertically and had things falling from the sky, or even if you had these guys move from this right side to this left side and bounce back, like Space Invaders. Do all sorts of things with that. So now that we have this, and this actually seems like it could be a game, you need some sort of game over message or game over kind of, like, realistically, to be a game, there has to be an ending. Whether that's a win or a lose or whatever, we need some sort of, hey, this is over. So, just like for those of you guys who've been in Unreal and Unity, this idea of having multiple scenes, we can trick this into creating multiple scenes. And some people like to do this with a Boolean value, where they have the playable time and then they have the game over. The way I prefer to do it is by, having numbers. And the reason why I do this is because, just like with Unity and Unreal and other kinds of engines, there's a good possibility you don't just have 2 scenes. Like, if you only have the option of 2 scenes, you have playing the game and not playing the game. But what if we want a title screen, a credits screen, an instruction screen, a play screen, level 1, level 2, level 3, level 4, and a game over screen? We need some way to say, hey, these are all things. So you could 100% call them by names, or I like numbers. Numbers take up less space in memory. So what we can do is we can, above our images, so above these images that we have, and we can say what's the images? We can talk about scenes. We can say scene control. And you can give whatever numbers you want. In this case, I'm going to say 1 equals game, and 2 equals game over. If I was to do this later down the line, yeah, 0 would probably be my title screen or my instruction screen. But this gives you more flexibility in being able to have multiple levels or multiple scenes or multiple things that you want to switch between. And now you could go ahead and take everything from like here down and put them into their own kind of functions, so they're specialized functions. Or we can use our best friend, the if statement. So first we have to say, hey, scene is a variable and it equals 1 by default, because by default we're in this playing mode. If you had a title screen and you called your title screen 0, you'd have it set at 0. So the next thing we do is we can say, okay, so, if button equals 1, we don't want to store clicks if we're on game over. So we can just nest inside of here and say, if scene equals 1, then or we could even do it outside, but eventually you would probably want some sort of left click, so you would make some sort of pseudo button to say, yeah, do you want to play again? Cool. So we can do that there. So cool. So that's done. And then update. Again, you just put all of this sucker in a nice big if scene equals 1, then, and we can just grab everybody and tab them over and add an end statement, and the same with draw. So we do have to have something that says, okay, so let's change over to scene 2. And if we run right now, you're going to see everything's still running, everything's still playing, everything's doing what it's supposed to do because we have it set at scene 1. Now if we were to set it as scene 2, you'd see nothing. So let's go ahead and come down where we have this. We have to think about how we want to do this. And we can do it where we have our movement. So barrel movement. This idea of, hey, move the barrel. And remember, we've got all this extra code here. And we can do this here because what we can do is we can check it kind of in this same area. So we can say, hey, if the barrel and their x value in that index that we're currently on happens to be less than 0, then game over. That's how we trigger game over. So in this case, our game over is just to switch from scene 1 to scene 2. So scene equals 2. That's it. Like, that's the logic. I know that seems like really overly simplified, as hard as everything else has been. Why is that so simple? And now we gotta wait for the barrels to get across. But it can be that simple. Like, again, part of this class is all about getting you guys to actually think about logic. And actually think about logic in a realistic way, in a way that's actually makes sense more than like your intro to logic class, which is very formal and this is how logic works, but how does it actually apply to you? So you see, we hit that game over, we hit that 2, and now there's nothing on the screen. So we have a game over function. Awesome, right? Like, it's doing things. But you don't really know it's game over. So I promise we are almost done. We're going to add some text. So the last two things that we're going to do is we're going to add text that says game over, and we're going to add a score so that when you click those barrels or when you shoot those barrels, you get a score added. And it's really, really easy. So there are a few different functions inside of Lua, or inside of Love, for printing text. And depending on how you want to do it, depends on which one you want to use. So printf is super fancy and lets you kind of define a rectangle in which to write your text. And so that one tends to be easier to use because you can center it inside of that rectangle. Whereas just plain old print will just print at a point and it doesn't give a flying flip about what you're trying to do. So if you come into Love again, and you can say, okay, I know I want to print. And it's going to say, okay, there's all these things, and you may have to like figure out where it's at. But the other way, you know that this text, this font is drawing on the screen. So you can say, so it's going to be a graphics thing. So we can come to love.graphics, and you can come down here and you can say, okay, I know that it's gonna be somewhere in here. It's gotta be here. It's gotta be print or draw or something like that. And sometimes you have to figure out where the heck they've hidden it, and I've probably gone past it. So print and printf. So okay, so I know I've got these two things. Draws text on screen. If no font is set, one will be created and once needed. Draws formatted text with word wrap and alignment. So, and again, it will tell you things can get a little bit angry. And it's got a long set of parameters, but you don't have to use all of them. These technically have to, like these extra ones, have to do with rotation and squishing and squashing and things like that. So you don't have to use all of that. You only really have to do the text, the X, the Y, the limit, and then the aligns. So, and we'll see that. Sorry, let me get down to where I'm at. There we go. So, if we're down at the end here and we have this one statement that says if scene 1 end, we can also say if scene equals 2, then what do we want to do? Well, we want to print some text out. Nice and easy. So the first thing we have to do is we have to say how big we want the font to be. And this is a lot of trial and error. But I know I want giant font, so we're going to say love.graphics.set font. And you can also define this inside of load. But if you want to change different font sizes, it's sometimes easier down here. So we're going to say new font, and we're going to give it a size of 100. New font is also where you can define the actual TypeScript. So it just depends on how you want to do it. And then we're going to actually write what we want to write. So love.graphics.printf. What do we want to write? Well, we want to write game over. Now, where do we want to write it? Well, we want it to be the top left corner to be somewhere around 0 and 200. And we want to give it a rectangle. So we want to give it a width for which it can write. And in this case, we're going to say 800. Or you could say the screen width if you wanted to actually be a good person. And then we're going to say, hey, center it in this 800. So now when we run, and and our barrels make it across the screen. Slowly. Which gives me enough time to take a drink. We get game over text. Remember, you can set the color, but make sure that if you're going to set the color, you set the color back to other things. And you can do whatever you want to do. But so, we've got text popping up. That's really what we need, right? So we have a game over screen. We have a game. Now, the last thing is that it would be nice to know how many barrels we've hit, right? Like, that seems pretty logical. Like, you want that satisfaction of knowing what your score is. So, if we come down here, if scene equals 1, then we come down and we look to where the end of this is. Because we don't need to be nested in any kind of anybody else's loop. We just need to draw on top of everything else. Remember, the lower this is, the more on top it is. So we can kind of copy this, because this is sort of what we're wanting to do. And we can paste it. We know that this font needs to not be this big, so let's say that the font's going to be 25, because that's a pretty safe bet. We know what we're going to want to end up printing is the score, with the colon and then whatever the score is going to be. We want it to be in the top left corner. At least I want it to be in the top left corner. And let's say 200. So that's going to give at 0, 0, and it's going to have a box in which it draws at a width of 200. And then it's going to be centered inside of that box. So when we run, you can see we have that score. And you can move it over, you can move it wherever. So this will get a little bit blurry if it's not pixel perfect, so you may have to tweak it a little bit more. But, we've got that pudding. That's a word. So now, let's actually add a score in. So inside of load, you can do it at the bottom or wherever, or with the barrels would probably be a good idea. We can say score equals 0, because that's true, that's where we want to start it. And down here we want to concatenate it. So concatenation in other languages, you use like the plus sign, or you use a couple other weird things. Inside of Lua, you use 2 dots. And that's it. Now we actually have to, if we run it, you're going to see the score is going to equal 0. And now if we come in, we have to say, okay, so, when we do everything else here, when we do everything else, so when it explodes, when we remove everything, we want to add 1 to the score. So we can come down here at the bottom again, or barrel spawn, wherever you want to put it, and we can say score equals score plus 1. So now when we run, and we start shooting our barrels, you can see we have a score that now pops up. So we have a score, we have a game over function, we've got, the valid starts of a game. What are some things that you could do to make this, better? Well, you could add more functions and make it cleaner. You could make your enemies move at angles, or in paths, or do random patterns, or whatever you want. You could add different types of obstacles or enemies, or maybe there are things that you have to avoid shooting, so you don't want to shoot certain things. You could constrain it so your bullets only start from the left, so you couldn't technically, click on top of something to shoot it. You could create a player character that follows the mouse, so it looks more like, something's actually shooting. You could add in some buttons or key controls, so you use the arrow keys and you move up and down and you press the space bar to shoot instead of the mouse press. You could add random speeds for your enemies, you could add power-ups, you could make it so that it's not an instant game over, but instead you've got multiple lives. Give it a background, make it look nice so that it looks like it's scrolling. There's lots of options, and this just gives you some basic ideas of how to do things. This would also work if you were making, more like an RPG sort of situation or an explore the world. It gives you some base ideas, which is what I want to do. And again, if you come into my REPL, which you guys have all been linked, and in the modules it has a couple of other options. The other one that I have videos of is this one called Chicken Drop, and board game, I think it's this one. But there's a few other things in here. There's I want there's a few others. There's one that's called a maze game. There's a fish tank. There's rolling dice. Those are the main ones. And all of these are things that you can come in and you can look at the code. You can see how I did it. These, again, are meant to be written in such a way that you guys should understand them and be able to follow them. So the maze game does not work that well. 100% does not work that well. But what it does is it, and again, with REPL, you're going to have some weird lag. And there used to be green blocks that showed where, I don't know when I did this. Oh, because this isn't the full maze. So it's got a timer going in the bottom, and game over, press space to play again. So it'll give you some of that logic if you want to see that logic. Fish tank is another kind of version of what we just made, more or less. It's click the fish. Where this one does have some fish that take points away that haven't popped up, or if they have, they're down further. So like this guy, he takes points away. So yeah, so you've got this kind of situation. You have, well, maybe how do I want to control dice? You could look at this one, which is just a roll dice against each other. So press the space, white wins. And it just counts up. There is a total down here somewhere. It just isn't showing because the screen is too blown up. And then there's Chicken Drop, which does have a video recording in your modules. And is highly... Oh, this is Pie Game. This is not the one that you guys want. You guys want the one that's... Where is it? Drop avoidance. Objects falling. Objects falling. They're the same game. I made them just in 2 different engines so that you guys could see something that was similar. Okay. Okay, so Chicken Drop. You can see where things are a little bit weird, but you click play, and you got chickens falling from the ceiling, and the whole point again is to just kind of And yeah, I know I do a lot of click games because these are easy to explain and they show you guys a lot of different ways to think about things like collision and yeah. And then the board game one is literally exactly like it sounds. It's a board game. Press space to roll the die. Woo, you moved. Woo, you moved. And it's not that fun. Like, you want to add more stuff in it to actually make it into an actual game. Because right now it's just, you know, press the space bar. You could add in power-ups, you could add in, you know, cards or backsies or whatever you want to do. But it's to give you guys some base ideas of how you can go about different things. Okay. So with that said, are there any questions? So, 100% you can check their location. Kind of the same way that we did to when we had the bullet going off the screen and we're like, hey, if you're off the screen, then delete yourself. You can do the same thing, whereas you would check to see, hey, is this within the screen? If it's within the screen, cool. If it starts to go out of the screen, or if it's, you know, at this point, then either change its direction or do whatever you want to do with it. What about, like, what do you mean by items? So, are you talking spawning? Are they moving? Oh, so spawning, it's literally what we did here. Which, not here. So, what we just did, is it going to be an unnamed? Yeah. So, yeah, so what we did here, where we had this kind of, this here, where we had a random. So, when you're wanting to get something, and I can start a new REPL to show you. New REPL. When you have an item and REPL.it, I'm just gonna grab the randomized code here just so that I have it already typed for me. So when you have this here function, I wish this would load with this for us, but that's too much to ask. And then function so when you have this here and you do kind of your randomization, you have your image, boom, equals love.graphics.new image tank underscore explosion 4.png. And when you go to randomize where it's going to actually spawn, or when you go to put it into its spawn, the big thing is that you have to check. So you'll say, okay, so let's create boomx, which again could be a table or whatever, but in this case we're just going to put one explosion up. So boomx is equal to, and we know that our x value, the lowest it can be is 0, because the lowest it can be is right up against that left side of the screen. So we can say math.random, and so that's going to be 0. And then we need to get the width of the screen minus however wide this image is. So to do that, we go love.graphics dot get width minus boom colon get width, and that will make sure that it spawns within this area, within the X. So to do it for the Y, we do the same thing. So boom Y equals math.random 0, because it can be all the way up flush to this top. And then the bottom, again, we need to make sure love.graphics.getHeight minus boom get height. And then we can come down here and we can do love.graphics.draw boom boom X boom Y. And now it'll always draw within your constraints. So it'll always stay within that area. So it's this is kind of the holy grail, are these two kind of things. This love.graphics get height, love.graphics get width, and then this get height get width of image. So it makes life nice. Does that make sense? Okay. Did you have any other questions? Alright. Yeah. So, alright, then that means that we are done for today. I will have some other lecture next week. I don't know yet what it's gonna be, but it will be something, again, it'll be like doing a simple mechanic or I don't know, animation or something like that. But again, it'll be 100% optional. No one will have to attend. As you can tell, it's 9 a.m. I get that in 9 a.m. class, nobody actually really wants to attend. But I will have stuff, and I am always here if you have questions, so send me a message if you need my help. So have a good weekend.